Today, let's talk about how does Hubble actually focus on something moving so fast in orbit around Earth. Aiming a telescope in space is something like trying to photograph just one person on a crowded beach from a deck of a distant swaying boat. So many special tools work together to keep Hubble pointing at specific astronomical object. So there are gyroscopes on Hubble. The Hubble's gyroscope are always facing the same direction, like needle on a compass. They sense if Hubble is drifting from the region that it has to point. So if Hubble is pointing at something and if its direction changes even a little, these sensitive gyroscopes pick up this motion and help to counteract this motion by bringing Hubble back to the point where it should be. So how does the Hubble actually change its direction? For this, there are reaction wheels on it. So what is a reaction wheel? So they use Newton's third law of motion. For every action there is an equal and opposite reaction. If the reaction wheels turn clockwise, Hubble's angle will rotate anti-clockwise. Hubble has a third instrument, fine guidance sensor. They are effective pointing control systems. Their role is to acquire and lock onto pre-chosen guide stars. So if Hubble has to study something, the team on Earth will choose two different guide stars on which the fine guidance sensors will lock their position to, and then Hubble will start its observation. So when the guidance sensor lock their position, even if Hubble drifts, the gyroscopes will measure its drift and the reaction wheels will counteract it. So the end result is a rock-steady telescope. 3 fine guidance sensors on Hubble. 2 are used to lock the position, and there's one more, which the best one among the 3 is used for astrometry. Astrometry science, which deals to determine the position and motion of the stars. When used for astrometry science, Hubble can search for wobbles in the motion of nearby stars that could indicate presence of planet around them. Determine if a certain star is really a double star or a single star. Measure the angular diameter of stars, galaxies and other celestial bodies. Refine the position, distance and energy output of a star. So the FGS can provide 10 times more precise position of the stars than if you measure it from the ground-based telescopes. Hubble has the ability to remain pointed onto a target with great accuracy. The level of stability and precision is comparable to being able to hold a laser beam focused on a dime that is 320 kilometers away. That's the distance between Washington DC to New York City. So guys, this was it for today. If you like the video, please give it a thumbs up. Share the video with your friends. You can watch my previous videos by clicking on the thumbnails that are here. If you like my content, please do subscribe. I'll make a new video every Thursday. And as always, stay curious, stay awesome.